Hi everyone, welcome to the webinar. My name is Clarisse. I work here at iBwave in marketing and will be your host today for the first time. I'm glad to have that opportunity, even if I prefer to warn you, I'm not a CBRS expert, but good news, I'm joined today by Dean Bubley and Jamel Ramoul from iBwave to cover our webinar topic, exploring the CBRS system, key applications, and use cases for the enterprise. So before we get started, I just want to cover off a couple housekeeping items. So webinar will be recorded and sent to everyone after the presentation. And please feel free to ask questions to our presenters by using the GoToWebinar question box. So now everyone's ready, let's start. I'm going to hand the microphone off to Dean. Hello, Dean.
Thank you, Clarisse. Thank you, and welcome to this webinar about CBRS. And I'm going to be talking for the next 20 to 25 minutes about a little bit of background on CBRS wireless and use cases, particularly for enterprise and vertical markets. And then I'm going to hand it back to iBwave to cover off some of the issues around design and planning for enterprise CBRS. So very quick introduction. My name is Dean Bubley. I'm an industry analyst and consultant. My company is Disruptive Analysis. I've been covering a whole range of areas, but actually private cellular, I realized I first encountered things like small cells in about 2001. It's been a long journey getting towards private cellular networks, and I think that over the next month we should see a significant step change in the way in which not just enterprises but also carriers and new classes of service provider deploy wireless networks, 4G, 5G, and I think it's going to be a very interesting, probably a couple of years ahead of us, not just in North America where this presentation focuses on, but also in other markets around the world, where there's essentially a global trend towards private and localized mobile networks, which should change a whole range of industry dynamics, and obviously that's occurring at the same time as 5G. So, you know, in terms of what I'm seeing overall, is there's probably, well, there's multiple industry trends and drivers at the moment, but probably the three things which leap out at me as sort of game changers at the moment are the 4G to 5G transition. First of all, and that's something I've talked about before on webinars and in some of my writing, and that has an effect of bringing in a lot of new use cases for wireless in enterprise, but also it brings in new challenges around spectrum, and so one of the things we're going to find over the next few years is the outdoor to indoor penetration of normal mobile networks is going to get worse, and that's partly because of the frequencies that are employed, but it's also new building and construction methods, and also the importance of covering perhaps parts of buildings for things like Internet of Things we haven't historically thought about. So yeah, that's all lumped in together. Another aspect that we're seeing changing is a shift over time from distributed antenna solutions to ones that are more active and driven either wholly or partly by small cells for cellular, and that brings a set of opportunities and challenges. It increases the potential capacity for cellular coverage in buildings, but it also makes it difficult in that we start having to think about backhaul and deeper fiber in buildings. And the other question is whether you have one small cell which covers multiple carrier networks and any private use cases, or whether we need to have multiple small cells on one enterprise network. And the last area I picked out in red is this idea of new models of spectrum allocation. Again, this is an international trend. We're running out of mobile suitable spectrum that can be provided on an exclusive and dedicated basis at a national level or large regions, both in terms of existing incumbent users that can't easily be shifted out of those bands, which means that sharing is necessary, but also because governments and policymakers are recognizing that there are business cases for smaller networks, and indoor and enterprise is one of those. So I'm not going to go through a in-depth discussion of exactly how CBRS works. There's a lot of stuff around on the web about this and a lot of other webinars, but I'll have a couple of slides of introduction just to sort of set the scene a bit. First off, we are talking about a band that's in the 3.5 gigahertz or 3.5 to 3.7 gigahertz range. So sub 6 gigahertz. It's 150 megahertz in total, which is a substantial amount, usable for, as we'll discuss, 4G or in future 5G. But perhaps the most interesting thing here is this term 3-tier spectrum sharing. And that essentially means that there are 3 classes of user going forward in this band. First off, there are the existing incumbent users, of which the main one to take note of in the US is the US Navy, but there is also some satellite usage and some fixed wireless usage as well. And for various reasons, that particularly the military use of this is not something that is going to be shifted around. That said, it tends to be only occasionally used. And so the theory here is that there's a large chunk of spectrum that is only used in certain places and certain times. So it should be possible to exploit that spectrum to make it more efficiently used elsewhere. I mean, to be honest, there's large chunks of the country where you don't get too many aircraft carriers, for example. The second tier, and this is going to come into effect next year, is what are called protected access licenses, and these look like traditional spectrum licenses where there will be an auction process in the future, and there's going to be up to 70 megahertz available of that 150, and they, if you like, have exclusive use within those 7 10 megahertz slices subject to auction. So it may well be that they're not all used in any one area. And then lastly, there's what's called general authorized access, which essentially is, it's not quite the same as Wi-Fi, and I'll come on to the architecture, but it's more open to general purpose use, as long as neither of the top 2 tiers are using a particular band in a particular place at a particular time. There's a couple of organizations that you'll come across the names of. There's the Wireless Innovation Forum, or WIN Forum, which sets the technical standards, and then there's the CBRS Alliance, which does the ecosystem building and also certification of the equipment. The other term that you'll hear used is OnGo, which is a brand that is being advanced by the CBRS Alliance to try to describe the services and the solutions that are being provided. This is going to be provided on a localized basis. There are about 3,000 county level territories, which will be sort of independent locations for the future licenses. That was a compromise that was reached over time of whether we're talking about originally the intention had been to have a much more fine-grained localization. There was a negotiation process between the large carriers, the FCC, and the potential new users. We've ended up with county as the quantum of territory for CBRS. In terms of the architecture, and again, there's a lot more detail available online, but the key things you should be aware of, first off is a series of sensors, particularly around the coastlines, called Environmental Sensing Capability, ESC, and they're essentially there to detect when the incumbent users are using the band. Perhaps unsurprisingly, the Navy doesn't necessarily want to tell everyone in advance when and where it's going to be using bits of radio spectrum, and so it's necessary to essentially sense it and then use that data to inform what essentially the spectrum database is. And there are going to be multiple providers of what's called spectrum access systems, SAS. A number of them have already been certified as the database providers, and they're, if you like, the lookup function to tell a particular base station whether or not they're allowed to use a given chunk of CBRS spectrum at a certain place and a certain time, and they'll be updated from databases of, say, things like the satellite locations, and then also the dynamic information coming from the ESCs. And then the actual base stations themselves are referred to as CBSDs, CBRS devices. And at the moment, there's two proposed classes of these, which roughly speaking correspond to outdoor and indoor, but they're actually separated by power levels. And again, the precise details of the specifications for those are available widely online. But certainly from an in-building point of view, mostly we'll be looking at the smaller devices, although for very large and dense areas of demand, so think like a sports stadium, we may well find that the outdoor class are used as well. So in terms of how we've got here, this has been quite an extensive timeline from the original conception of CBRS back about 9 years ago, an identification of this band as potential for innovation and novel uses. And we've been through multiple cycles of regulatory proposals and rules, workshops, and input from different stakeholder groups, whether that's the incumbents, service providers, enterprises, solution vendors, and so on. The standardization was done primarily during the 2014-2017 period with some initial test deployments. And really, it's been in the last 12 months that we've got closer to actual deployment, and there's been a series of testing phases of the ESCs, of the SASs, where you have multiple bodies involved, whether that's the FCC, whether it's the Department of Defense, the NTIA, to check that all of these things work as they're supposed to. And obviously that's pretty critical given the need to protect the incumbent users. And we've certainly seen in the last 6 to 12 months the ecosystem becoming a lot more functional. I've been to a number of events where there's systems integrators talking about their plans. The first devices have been made available, and to be honest, it's all about to kick off now. The key date that's been announced is in the middle of September. There's going to be a launch event, and what are called the initial commercial deployments, ICDs, will occur. And there's going to be then subsequent to that a review, almost like those will be commercial field trials, and there should be a fairly rapid review process, more devices coming online in the second half of the year. Also, interestingly, at the moment, this is around 4G, but the 5G specifications are due out as well in the same band. And we should expect that these the protected access license auctions should take place probably in the middle of next year. And so we'll see a mix of the general access and protected access usage really kicking in during 2020, 2021. And then, well, there's different predictions, but if you look out 3 years' time, there might be hundreds of networks, there could be thousands of networks, and I'll talk through the use cases in a second. So here it's worth saying that there's two classes of use case, and here I'm focusing on the indoor and enterprise. There's also a bunch of really interesting stuff that's going on outdoors with CBRS, whether that's fixed wireless access or large remote deployments in ports or mines or offshore wind farms or something like that. That is perhaps a discussion for another day. It's an area that I cover, but obviously this particular webinar is focusing on enterprise, which primarily in this case means indoors. Obviously there will be wide area outdoor use cases for utilities and others, smart cities and so on. But here I want to talk more about indoor. And for what I'm seeing, I mean, the main, once you start talking about enterprise, it becomes very clear that there is no one size fits all. There are hundreds of use cases with different levels of importance, different levels of integration with the carrier domain, with IoT, with enterprise fixed networks and their historic voice and data infrastructure. The things I would pick out are indoor cellular is obviously going to be an important use case here, which essentially is bringing the outdoor mobile network indoors and using CBRS as a coverage solution. And that can either be for a single network on premise where perhaps an organization has cut a deal with a particular carrier and wants to have better indoor coverage using, it could be their normal license bands, but it could also be CBRS. But where it gets really interesting is whether you can have a neutral host approach which involves having a single cellular network using small cells and CBRS, which essentially acts as a multi-tenant radio network for multiple different cellular carriers users to essentially roam onto. In the same way that you roam internationally or in rural areas, it's like an indoor roaming location potentially. And there's various business models that are emerging around that. Then we are going to see some interesting use cases around purely private enterprise cellular deployments. And that could be for localized voice networks. It could be for localized data and IoT connections. So you might find a hospital, for example, that wants to have a private cellular data network for asset tracking. For its putting tags on bits of equipment. You could well find that companies want to replace their walkie-talkie systems with essentially a private cell phone network on site, and I'll come across a number of other interesting applications there as well. In some cases, you will find this term I'm using here is MVNO onload, and this is particularly related to cable MSOs and other mobile virtual operators that essentially have to today pay the national operators wholesale prices. So if you're using Comcast Mobile, Xfinity Mobile, they are having to pay their host network per gigabyte. And if they're offering a flat rate plan, then clearly they're incentivized to try to reduce the amount of traffic that goes over that wholesale deal they have with their provider. And if they can essentially put your phone onto their network or a wholesale network on cellular, which may also help because you might have the Wi-Fi switched off, then they can save money. I'll talk about the relationship of CBRS and Wi-Fi in a bit, but my view is that CBRS is going to be complementary to Wi-Fi. I do not buy the views expanded by some in the cellular industry that 4G or 5G or private cellular is a Wi-Fi replacement. I think that has a lot of flawed assumptions within that statement. But I think there are certain use cases where it can do stuff which Wi-Fi can't, particularly where you have devices that are moving around. So imagine robots in a factory, for example, may struggle, particularly if they have to go indoor and outdoor between buildings, may struggle to be connected on Wi-Fi. And then we can expect this to end up as a proper innovation platform. There will be some surprising things that emerge over the next few years. So I spoke to someone in the hotel industry a while back, and they were looking at whether or not they could have virtualized enterprise virtual operators, where they can essentially allow to have a wholesale deal, almost like a retail concession with perhaps a brand or an internet company. You could imagine having a sports stadium or a hotel venue where looks like on your phone that you're on the, let's say, YouTube or Instagram cellular network, and it comes up with their name in the top corner of the phone. And that starts bringing in all sorts of interesting possibilities. You could also imagine that being used for, say, international visitors, where you could have perhaps a deal in a large resort where if you have visitors from Japan or China or somewhere, you could almost like take them off of their roaming relationship and give them free access locally. So I think we're going to see a lot of interesting innovation there. And sort of when you break this down in terms of the types of network you would use for these different use cases, realistically today, you have a choice. You have Wi-Fi in building, you have the public cellular networks from Verizon or AT&T or whoever, T-Mobile, and then you have private cellular, which is what we're talking about here. And today, there are very, very few private cellular networks around. The ones which do exist tend to be in remote locations like mines and oil fields. Sometimes ports and airports have their own cellular networks as well, but there's very little that is indoor. And this is despite this has actually been talked about as a concept for about 13 or 14 years. I worked with a company in about 2006 that had a 2G and 3G solution for enterprise cellular, which never caught on. But this is perhaps something that we will see now really shift. And as I say, I've got the use cases split out between the indoor coverage of outdoor networks, the MNO indoor coverage, the local, what I call IT and internet LAN, which is what you connect your laptop or your printer to, and this is Wi-Fi's main domain today. There's IoT, which is some of it is static, like lighting and heating controls. Some of it is moving, like robots and vehicles. OT stands for operational technology, and that's industrial machinery. So it could be production plant in a factory, and then voice usage, and then there's going to be a bunch of other specialized use in particular industries. So, broadcast networks, for example. And I think that some of these are going to be real focus areas for CBRS. I think that we will see indoor coverage solutions, typically on a shared network basis for both 4G and 5G, being a major emphasis for CBRS in future, and particularly because it means you can use perhaps one small cell to cover multiple network operators rather than one small cell or one signal source per operator. And so it may well bring down the overall costs of doing that, and also allow the venue to monetize almost like a reverse roaming model in some cases. I think that IoT use cases are going to be important, particularly ones which cover the mobility aspect. Bear in mind that this is 3.5 gigahertz, so it's still fairly going to be a fairly dense grid of access points, and Gemma will probably talk about that towards the end in his section. And then I also see a real interest in people shifting away from their legacy two-way radio systems, whether that's for sort of relatively low end usage for, I don't know, venue staff in an entertainment venue, or perhaps some of the more critical and safety critical use cases in health and public safety, although obviously that comes with a regulatory set of higher set of requirements from a quality and performance management point of view. It's very difficult to generalize what this means for individual sectors, and I think that we're going to look back in 2 or 3 years, and some of these will have become workable at scale, and some will be nice ideas that are difficult to realize in practice. My expectation is that hotels, offices are going to be quite high on the list here. There's a lot of interest in industrial markets, manufacturing, for example, medical, but I think they may well take quite a long time to come to reality, because a lot of companies in those sectors are quite conservative. They plan their connectivity solutions as part of maybe an entirely new production line or manufacturing cell, and so I think that we'll see a fair amount of caution, but there's definitely an interest, and that's something which is not just in the US, but also internationally. If you look at Germany, a lot of the car manufacturers are looking at private cellular, and a similar band, not quite the same as CBRS, is likely to be licensed there. I think that in venues with lots of visitors, so airports, stadia, hotels, there's a lot of interest here, particularly as an additional capacity source along with Wi-Fi. And I think in some cases it can be for private deployments, and in some cases it will be the cellular carriers wanting more capacity. And this essentially ends up looking like cheap extra capacity. And I realize the picture in the bottom right is actually Shanghai, but leave aside the location. I think that some extended deployments in cities is likely as well. There's a really complicated ecosystem here, and I don't have time to go through the roles of all of the parties involved in CBRS, but as well as the traditional network providers, the large network equipment providers, we can expect there to be a lot of other new participants. So the tower companies are looking at indoor opportunities. We're seeing communities and municipal authorities in some cases looking at this as an opportunity for their, it could be schools, it could be public buildings of other sorts. We're going to see a sideways move from venue owners, the distributed antenna and cellular indoor providers, and a lot of interest from industry vertical specialists. I think we'll find that companies that have historically done, I don't know, hospitality systems for hotels, or airport technology are looking very hard at this, and the same in, for example, ports and transport hubs as well. So I think that this is going to be a real sort of Cambrian explosion of new entrants, partnerships. Not everyone is going to get this right. There's going to be property companies that look at CBRS and think, if they're building a new property development in a city, can they own the network and almost like charge rent to the cellular carriers? Possibly. It depends then down to, there's going to be some interesting negotiations as to sort of who has the power in a particular vertical and a particular size building. I don't think we've got a full handle on those dynamics yet. One thing I will say before I hand it over to Jamel is the radio part of the network is only part of the story for CBRS. And this is where there's a divergence with Wi-Fi, in that Wi-Fi is fairly self-contained. It's a data network. It connects to the internet and the private LAN. Here, we are essentially talking about building private cellular networks, and they are pretty much small versions of what a carrier deploys. So it comes with a core network. There may well be, for a fully private network, a need to have SIMs and eSIMs issued by the enterprise themselves. You have to think about how the backhaul works, the timing sync, the transport networks, all of the operation and billing software stack. This is not going to be a trivial project. And I think the interesting thing for me is if we look at how we get to the endpoint of private cellular being as easy to deploy and manage as Wi-Fi, a lot of this is going to have to be cloud developed, and a lot of the complexity is going to have to be hidden from the enterprise user. Some of them, the enterprises, will be very sophisticated, but if you want to have a medium-sized law firm deploying this, they are not going to be hiring people who are specialists in cellular core networks, whether those are 4G or 5G core. And similarly, they're not going to want to have to deal with roaming and interconnect relationships. All of that will have to be a managed service. And I think we'll find that some of the carriers and the wholesale telecom providers, and also the cloud companies, the Amazons and Googles of this world, will be offering various of these functions as cloud delivered managed services. And I think we'll see additional areas such as edge computing playing into this as well. And one thing I'll note is that on the right hand side, there's this hexagon with physical design, integrate and build. And clearly one of the challenges is going to be, how does all this stuff get actually rolled out? Are there going to be enough engineers? Are they going to be the right tools? How easy is it going to be to build the business case? And I think that we'll see various of them evolve over time to as experience curves grow, and also as more people get involved. Outside the US, it's worth saying that there are similar but different trends going on at the moment. A number of countries are looking at localized spectrum and spectrum sharing approaches. Some of them are going to be dynamic models similar to CBRS. Some of them are going to be geographic areas provided on a first come first served basis. I think it's going to take about 3 years for all of this to really shake out, and that has some implications if you're a multinational organization and let's say you've got offices in multiple countries in North America and Europe and Asia. I think that there's going to be a fair amount of systems integration and patching together slightly different sizes of networks and different ecosystems for now. The ones I'd point out, the German market is aiming mostly for 5G and industrial applications, particularly in factories and ports, and that's between 3.7 and 3.8. So I realise there's a typo there. The UK, where I'm based, is also doing some really interesting stuff in 2.3 gigahertz. There's this new band of 3.8 to 4.2, which is going to be available on a localized basis. And also 26 gigahertz for indoor usage. And there's an interest not just in indoor use, but also rural markets and industrial. I think that's going to be a very interesting thing to watch and see how that evolves in terms of speed compared with CBRS. The last one I'd say is that there's quite a lot going on in Japan and other markets such as Sweden, Netherlands, France looking at this as well. So with that, I'm going to just sort of point out that one of the challenges as we go towards 5G and also new use cases like, I don't know, connected vehicles. You can imagine something like an underground parking lot in future. And the question is, who is going to be providing coverage for your connected vehicle, so that if you're standing in the lobby of the hotel and you press the button on the app on your phone for your self-driving car saying, come and meet me at the entrance, but the car is parked 3 levels down in a car park, is there any coverage? How does it know that you want to come and pick it up? It will need to be connected somehow. And at the moment, there's a lot of use cases like this that no one really knows what network we're going to be using, what technology, what spectrum, what ownership. And it's things like this that CBRS has the opportunity to fix. But there's going to be 100 or 1,000 use cases that are individually interesting. But we're going to have to go through a period of experimentation and innovation first, I think. So those are my coordinates, and with that, I would like to now turn over to Jamal Ramul from iBwave, who's going to talk you through some of the design aspects of it. Let me hand over the presentation to him now.
Thank you, Dean. It's quite interesting presentation. Let's talk now what iBwave can do to help you design your CBRS network. First of all, let me just present myself. My name is Jamal Ramul. I'm a sales engineer at iBwave. I joined about a little bit more than 2 years ago, and I have experience in the wireless industry, mainly in the cellular. I've been working with a carrier here in Canada doing design, cellular design using the iBwave software. So for those of you who don't know iBwave, we are the worldwide standard for in-building wireless network design and documentation. We've been around for the last 16 years. We help many customer design network, especially operators. We have over, I think now it's almost close to 1,200 customers in different countries around the world. We have the largest indoor database. It's technology agnostic, so you have anything you need from small cells to coax cable to connectors to DAS components to a Wi-Fi access point, a switch router, anything that's needed for a design and for a bill of material. And the database is also manufacturer agnostic, so it's rich from different parts, from different manufacturers, almost updated daily. There's more than 300 manufacturers doing that. And the iBwave design, the flagship tool we have, is actually the tool of reference for stadium. Any large event, any large stadium around the world is most likely designed, or the network is most likely designed using iBwave. For example, the last FIFA World Cup in Russia, all the stadium network design was done using the iBwave software. Some customers that are using our tool, mainly all the big operators around the world, all the big names like the AT&T, Verizon, T-Mobile in the US, for example. The system integrators, companies that are doing design for operators, for carriers. And also the OEM, they use our tool either to model their parts in our database or for their professional services. Then different products we have. The main tool that's been around for the last 16 years is iBwave Design. This is the tool that will allow you to do CBRS design and also any type of network, 4G, 5G, Wi-Fi, IoT, public safety, also cabled or wired network like Ethernet, LAN design or fiber design. All the cabling is also available. We have a mobile app running on Android. This is really useful for site survey, to document a venue, to do high-level design, to put some small cell or some access point to have an idea of how many components I need for this floor plan. And it's also really useful to capture the data. Now we're talking about deployment, like CBRS deployment, but how can you actually visualize the network when it's deployed? Our tool comes handy because it's integrated with third-party collection tool. For example, if you want to use a scanner, you could capture CBRS band, you could capture all 4G bands, 3G bands, Wi-Fi bands, and even public safety bands. all in once and then visualize the heat maps in our mobile app right away on site. Then we have the Unity platform. It's a server or cloud-based collaboration and project management platform. Many of our customers are using it to store all the project in a central location and have some kind of data mining and data analytics to kind of follow what's happening with different project, who's working on what and what's the status, and also to run different reports. It has a really powerful report engine. We have the Wi-Fi tool. The iBwave Wi-Fi is the same as iBwave design in terms of functionality. It's just the database is lighter. It only contains Wi-Fi components, and it also has a mobile app under it. And we recently launched iBwave FiberPass. This is only dedicated to fiber to the home deployment, MDU or MTUs. And we have some carriers here in North America using it to do their fiber inside buildings design and documentation. So this was about iBwave. Let's switch now to the software itself and how can you do a design. Actually, I'm going to show you a demo, a design from scratch. Let's say you have a floor plan and you want to do a quick design. How can you do that? This is the iBwave design software. When you launch it the first time, some of you might already be familiar with it, but if you never seen this software, it has like a main window with like latest news and some tutorials here to learn a little bit about the tool. Has menu on the top similar to Office with tabs and functionality. Quickly, if I want to start a new project, for example, here I name it like CBRS demo, and just gonna select, let's say, Imperial and then DBIS gain. And then I create a new project, and you see I have two new tabs. One is the design plan, where I will have like my diagram, my network diagram, like a vertical view of what is connected to what. And then I have floor one by default. I could have as many floors as I need for my building. If I right click on my floor and go to properties, I will be able to load an image file as a floor plan. Any type of image, JPEG, BMP, GIF, whatever, or PDF. But if I have a CAD drawing, it will make things more interesting. So here I have a sample DWG file or AutoCAD file. When I load it, the tool will help me clean it. Usually a CAD drawing, when you load it, it will come with a lot of extra stuff. You don't need them, so the tool will help you clean them. You just need to click on any layer. It will highlight the layer and you just need to uncheck it. So any text or any logo, any lines that are not needed, you could uncheck it. And then once you're done with that, you could use the same thing, click on any wall and then assign, you see the highlighted layer, assign a material. For example, we can assume this one is concrete, and then interior walls, we can assume it's drywall, and then maybe the doors. If I click on the door, I could assign like door wood, and I could also adjust the height. Let's say this one is from 0 to 3 meters or almost 10 feet. I could adjust the door height and make it like 8 instead of 9. And all other layers that are checked without material will be converted into image. So here quickly, I just loaded a CAD drawing, and I have the CAD drawing loaded here. And you could see that if I double click on the wall, I'll see the properties or the RF property of the wall. You have the conductivity, you have the transmission loss, and you could notice that the transmission loss gets higher as the frequency gets higher. So if we go between 2.4 and 5 gigahertz, it's almost double the value. You don't have just the loss, you have also diffraction loss, you have refraction loss, the electricity permeability. So this will be taken in consideration for the link budget calculation and for the heat map. And then the only thing I need to do is to scale my floor plan. And let's say this is 150 feet. And then I could, if I don't have a CAD drawing, I have the drawing tool here. I could draw any walls I want or any inclined surface, and I could also draw horizontal surface. This will serve as my ground floor, and it will also serve as the ceiling for the floor below. So it will be taken in consideration for the reflection on the floor and then the loss between floor. So very quickly, I'm just going to draw this horizontal surface to make it as my prediction area. So everything will be calculated inside this surface or inside this area and nothing outside in the white space here. So here I'm gonna right click, I'm gonna define it as prediction area. Now that my building is modeled in 3D, actually this is just the floor, but you could model the entire building if you want. So here you have the walls, and actually we're missing the horizontal surface, and you have like the floor, and you see like the concrete and the drywall, and you see the doors, and then you could start designing your network. And let's say you want to use some small cells for your CBRS design. You could go to signal source, go to small cell, and then you will have different manufacturers here. And we're just going to use one of them. This is this model particularly we are trialing here internally. And you can see that you have this small cell support 2 bands. It support the band 41, which is 2.6, and band 48, which is the 3.5 all the way up to 3.7 gigahertz. It's 2x2 MIMO and has 24 dBm output power. And you could see the antenna pattern for 2.6 and the antenna pattern for 3.5. Since we don't need 2.6, we're just going to turn this one off, and we're just going to use the 3.5. You see here it's already preloaded. You get 10 megahertz channel, and since you don't know which channel the SAS will assign, and you don't know how many you will get, I believe you can get up to 8 channel at a time, so maximum 80 megahertz out of the 150 megahertz. And so but worst case scenario, if there is other users in the same building, let's say on other floors, then you may get only one channel. So if you're using only one channel, I could leave it as 24 dBm plus the antenna gain. This antenna has about 5 dBi gain, about 6 dBi gain. So I am respecting the limitation of a class B device, which is maximum 30 dBm ERP. So 24 plus almost 6, I'm just a little bit lower than 30. I could use this one, and then I could start putting on the floor plan. And if I'm thinking as a Wi-Fi design, I would need to put them in like rooms and stuff like that. If I'm thinking as a DAS designer, I put them like in corners. The thing is that cellular is not as Wi-Fi. You don't need to contain the signal as much as you do for Wi-Fi. This is because in Wi-Fi, if I have an access point here, the wave guiding effect will make the coverage go all the way down in this hallway, all the way down in this hallway. A client here cannot hear the client here. Since it's a listen before talk, it may cause the hidden node effect. But in cellular, the small cell will have a scheduler and will assign subcarrier to each device. So there is no problem with that. So you could do that if you want. The only concern here would be the interference. This one would interfere with this one since we're using the same channel. Now what I could do is actually check the antenna contour. I'm gonna go to properties, use the ray tracing model, which is the most accurate algorithm to do prediction. And then I'm gonna go to my 3.5 and what is my target coverage. But for RSSI, since we're using LTE, we're targeting something like neg 75, which is around neg 100, neg 105 RSRP. And it's actually neg 102 since it's 10 meg channel, so it's 27 dB difference. Then I could activate this and see actually my antenna contour. Am I covering my floor correctly or not? And what I could do is just move the small cell around to try to maximize my coverage. And do I need to cover the hallways or not? Where are the area that I want to target this next 75 RSSI? And once I move, you see I have area here. Maybe I need more small cells. So before even running any heat map, I know I have a high level idea of what is my coverage with the small cells I'm using. And once I'm happy, let's say I need to add another small cell here or something, so I could use the clone tool, for example. I'm gonna clone a small cell here and add let's say one here to add more coverage. But still I have some gaps here, but maybe I don't care about this area here. And then I could run heat maps. Then I create an output map and the 3.5. And what I'm looking for in CBRS is LTE. So it's LTE RSRP. So I need LTE RSRP here. I could either see per small cell or combine all of them to see the coverage in the entire floor plan. So now I don't need the antenna contour. I'm just going to run the heat map here and see actually what is the coverage on this floor using this set of small cells. And you see we have like hot areas where you have good coverage, and then cold areas where you have weak coverage. And you could add the legend, so indoor prediction, and this is what you have. So usually carriers will target about neg 105 as minimum. So you see here we have 88% of the area covered. If you want to cover more, let's say 90% or 95%, then this means that you're not covering the entire area correctly. Maybe you need to move a little bit your small cell around, or adjust the power, or add more small cell or something to get this this coverage. But what is critical in LTE design compared to Wi-Fi? In Wi-Fi, you're looking for a CCI map to know how bad it is, your interference. In LTE or in CBRS, you're looking for SINAR map. So if you do your SINAR map and you want to combine, you could see per small cell, or you could see overall what is your floor plan. Then you run this one, and you will be able to see that my SINAR is good next to the small cell. So you have 30 dB SINAR, which is good. But as soon as you go away from the small cell, then the SINAR is bad. You see here that the green, the light blue one is 2 dB SINAR, which is bad. And you also have some area here with like negative values because there's no coverage basically. And all those heat maps, you could actually see them in 3D. And then you have like some kind of wow effect to show that to the customer and see, okay, this is where we're going to install the small cell. This is the coverage we're getting. And you could also run the cabling if you want to put any small cell controller, for example, or something. So if you put a controller here, I'm going to put a generic small cell manager here. So you could put, let's say this is my equipment room, and then you could connect using Ethernet cable, for example, or fiber, depending on what the small cell are they're supposed to be connected with. So if I use, let's say, Cat6, and then I have here, and then I could connect to the small cell manager and so on. So I could do all the connection, and then I have my bill of material after that to have the total number of small cells, and then total length of the cable I use, and then the connectors. So here I have how long I need from cabling, how many connectors, how many small cell manager, and how many small cell actually I need to deploy. Then you could export it to whatever format, Excel, PDF, or any other formats. And at the end, you could end up with a complete project. Let me just show you one here. So I'm going to show you a completed like hotel project where you have like a DAS and a Wi-Fi in the same project, and you have all the floors defined already in 3D, so you could see what a completed project would look like, and how you could also do the capacity planning for this particular project. So here we have a hotel. You have the design plan. Like I said, it's a vertical view of your what is connected. So in floor 1, we have like those access point connected to different switches, and then you have the DAS here with a different coax and a different fiber connected to different floors. And then you have other pictures, let's say the capacity, how it's defined, how many users per floor, the different hotspots, the split between Wi-Fi and cellular, and then also the split between 2.4 and 5. And then if you go to, let's say, floor 1, you see the heat map here, and you could see actually the building in 3D. So a complete building will look like this. Just activate this. This is the hotel with the different floors, the entrance, the different windows. You also have an outdoor area where you have the swimming pool. So if I remove the prediction, you'll see that what we have. And then you have also the possibility to see where are the different the different cable going. If you activate wireframe, you could see like here's where we have the cable going in the corridors and where we installing all the antennas or all the equipment. With this, I complete the demo section, and then we're gonna jump to the questions. Do we have any questions, Clarice,
Yeah,
maybe?
thank you very much, Jamal, for the demo. I have two questions. So the first one is how different is CBRS design as compared to traditional Wi-Fi?
Yeah, I can take this one maybe. Like I was showing in the demo, the Wi-Fi is on 2.4 limited to 3 channels, 1, 6, and 11, and in the 5 gigahertz you have many channels. But you always rely on your CCI map. I would say that the Wi-Fi is like the Wild West. Anybody could use any channel. So you're not protected. Your CCI could be good one day, it could be bad another day. In CBRS, this is different. The channel are assigned by a SAS, and you're using those channels, and you kind of have, you know, in advance that if somebody else is using this channel, if he's using a CBRS design, he will be assigned other channels unless he has higher priority. Then the SAS will request your small cell to move to a different channel. If let's say the military is transmitting on the channels you're already using, then the SAS will ask the small cell to move to another channels if they are available. If not, they will ask the small cell to stop transmitting or to reduce the power, the time that this military is transmitting. This is one different thing. The other thing is that the LTE is much more efficient than Wi-Fi in terms of handling multiple connections at a time. So the LTE has scheduler, LTE has subcarrier, which Wi-Fi 6 is bringing, but the actual Wi-Fi right now cannot handle multiple users. It's one user at a time, and the spectrum or the airtime is unfairly shared between them. While in LTE, it's kind of allocating subcarrier for multiple users at a time. Then there is other difference when you're doing like design in terms of power. For Wi-Fi, you need to adjust your power to your client power. In LTE, you don't really need to do that. You could transmit higher than what the uplink is. That's not a problem compared to Wi-Fi.
Jamal, one thing is, Dean, one thing I would say is you also need to think about the differences in application and use case and device type. I mean, obviously, Wi-Fi often will be used from a static location with a laptop or a tablet, but also phones as well. And although there's a number of sort of M2M and IoT use cases of Wi-Fi, they're often static devices like thermostats and maybe conference room displays. Whereas we might expect with CBRS to see a bit more mobility and potentially more use of sort of going inside and outside the building. And then it's going to also depend on whether we're looking at a network which is primarily used for essentially roaming from the public cellular network on a phone, or if it's a purely private network. And both of those will have implications about which parts of the building you need to cover, and as well as the radio side of this. Obviously, if it's a pure private network, you also have the other architectural elements like the core network to think about, and how everything interacts.
Yeah,
all right,
definitely.
Yeah. Do you want to add anything, Jamal?
Yeah, the mobility part, I think it's really important because LTE is much more efficient in handling what in the Wi-Fi we call roaming, in cellular we call handover, compared to Wi-Fi when you're moving, you have to disconnect from an access point to another one. In the LTE, you don't need to do that. You could connect it to small cell at the same time and then switch from one to another. You could actually use carrier aggregation and connect to 3 small cell at a time on 3 different channels, and have, let's say, three times the throughput since you're connected on 3 different channels at the same time.
Okay, interesting. Thank you. We're going to move to the second question. So it's how do you expect to see CBRS deployed in building in a neutral host environment, for example, with multiple operators in place? Will each deploy a separate CBRS system to accommodate LAA, or will there be a mechanism for operators to share on CBRS RAN?
Right, that's a really good question. I've been looking at the different models for neutral host for some time now, and a lot of it depends on whose network it is, whether it's the venue owner, whether it's a third party specialist, essentially like the equivalent of a tower company that's running an indoor network as a managed service, and also whether the relationship they and the roaming, whether they're able to negotiate roaming deals with the carriers, or if it's the carriers doing their own implementation in building. So it's there's no one size fits all on this, and what you might get in a Las Vegas hotel and resort might be very different to what you get in a factory or a government building or something like that, where you might have different rules on collaboration between the carriers. My understanding is that there's some legal restrictions in private enterprise buildings which limit the amount of collaboration that's possible between carriers, whereas if it's a government building, it's possible for everyone to work on a more consortium-based approach. The other question here is whether we're going to be talking about the protected access licenses or the general access. And so, I can imagine theoretically you could have a particular location where each of 3 or 4 of the national operators or cable MSOs have got 1 or 2 channels of the protected access, and then you're going to also have the general access band as well. So I think there's going to be a lot of different permutations here, and I can imagine that there's going to be some super congested locations like stadiums where people will want to use both the protected and the general access bands, as the channels if they can. So I think that we're going to have to sort of probably wait and see a little bit until a year or so in terms of exactly what the CBRS neutral host endpoint looks like. I don't know, Jamal, I don't know if you'd seen anything on this as well.
Yeah, I would be interested to see how a neutral host will do, how they will offer like a private network and then roam to the other carriers, and how the roaming will happen, and how the transfer or the wholesale will also be dealt with.
I mean, I think a lot of it's going to come down to what happens next year with the PAL auctions. And if you start finding new players buying PAL licenses in, I don't know, I can't remember, is it Clark County for Las Vegas, or parts of busy metropolitan areas, they become de facto wholesale operators for that region, and they have a lot more market power to negotiate essentially roaming relationships with the macro carriers for capacity. Whereas if it's the carriers themselves who own the spectrum, then the relationships are going to be different. And I think there's going to be some interesting calculations and analysis of how much to bid for spectrum in any given location, which is probably a little bit early for me to try to speculate on.
All right. Thank you. Next question, what are the main impacts in the CBRS hardware if you want to reuse existing LTE hardware implemented?
Well, I can take this one, I guess.
Okay, go for it.
Since the CBRS is a new band for the LTE, so far the LTE was used only up to 2.6 gigahertz. And some rare case on 5 gigahertz for LTE-U or LAA. Any DAS equipment right now already installed may not work since it's limited to 2.6. You need to check the cabling, you need to check the antennas, you need to check your DAS component. If it's an active DAS, for example, you need new RF cards. In terms of small cells, actual small cells deployed right now, most of them, they only support up to 2.6 gigahertz. Very few of them supports 5 gigahertz for LAA, but new small cells are required for 3.5 gigahertz up to 3.7.
And also, they will be separately certified as CBRS compliant CBSDs. And on the other side to it is they also have to have the capability to speak to the SaaS systems either directly from the small cell, or there is I think it's called a domain proxy function, which is sort of an aggregation for a multi-access point building.
The only thing that might be reusable is the fiber connectivity to the existing small cell. If you have, let's say, spare fiber, or you replace the small cell and you reuse the same fiber or the same Ethernet cable, depending.
All right. So we're going to move to the next one. I'd like to know if CBRS is related to 5G and telco or just an extension of Wi-Fi.
As I can see, there's also another question about will CBRS and Wi-Fi compete or complement? And in a way, I would say it's almost a third category. I think that, well, first off, CBRS is today 4G, not 5G, although the 5G specs are coming as well. And I think that we will see, as I did in my presentation, there are use cases which are essentially telco related. So CBRS will be used by telcos or on behalf of telcos to provide in-building coverage. It will also have some small overlap with the use cases of Wi-Fi, although I don't expect it to be a large competitor, because a lot of the devices like laptops and tablets, very few of them have cellular modules, and I don't expect that to materially change anytime soon. So there's still going to be a lot of demand for pure Wi-Fi solutions. There's going to be some use cases which could use either. So smartphones where people may or may not have the Wi-Fi switched on is a good example. But it's also going to depend on whether it's used for the in-building coverage of the outdoor network, or whether it's used for private IoT and connectivity, essentially more as a wireless LAN, a wireless local area network technology, as part of the computing and IT infrastructure. So it's almost going to be a three-way Venn diagram, I would say.
All right, thank you. Is CBRS available in the unlicensed bands? If so, who is providing the service?
No, CBRS is very specifically the name of this 3.5 to 3.7 band. There is unlicensed 4G and 5G, of varying sorts. There's LAA today. There's another technology called multifier, which doesn't need an anchor band, which is used in Japan. I think it is in 1.9. 5G will have options for both anchored and non-anchored unlicensed, but CBRS is something different. It's shared spectrum rather than licensed or unlicensed.
Okay, thank you. The next question, we are being asked to add mid-bands, CBRS and LAA 3.5 to 6 gigahertz to traditional hybrid fiber coax design. Do you see this as a viable option, or are these bands better suited to FTT-based systems?
Jamal, I think that's yours probably.
Yeah, Jamal, can you cover it?
Can you repeat the question, please?
Yeah, the question is, we are being asked to add mid-bands, so CBRS and LAA 3.5 to 6 gigahertz to traditional hybrid fiber coax DAS designs. Do you see this as a viable option, or are these bands better suited to FTT-based systems?
I think it's the same answer as before. Can you reuse the existing components? In an active DAS or hybrid DAS, you would need new components, you would need new RF cards, and not sure that the existing cabling are compatible, or the existing antenna might be more difficult to replace everything, and easier to use fiber to, if I'm understanding well, fiber to the equipment directly. Then it's a small cell design, right? So you put small cell on 3.5 or on LAA, and you connect directly fiber to that particular small cell. Some small cell do have external antenna connection, so you could use a small DAS connecting to this particular small cell if you want to cover a bigger area than the internal antenna of the small cell. This is also possible. I would see this as a more viable solution.
Okay, thank you. We're going to finish with a couple of questions. So they ask practical use of CBRS to cover spectrum gaps for rural areas. Maybe Dean, you can cover this one.
Yeah, I mean, obviously that's a little bit outside the scope of this webinar, but I'm certainly seeing a lot of interest of CBRS for the wireless ISPs, for things like fixed wireless access in rural, for a good broadband solution for both residential, but also for small business and enterprise. We may find some other enterprise-related outdoor or rural use cases, say in the agriculture sector, or maybe for utilities. Yeah, and I certainly think that we'll see some quite significant innovation there, simply because it's going to be lower cost spectrum than traditional licenses. But say it's a little bit outside of the scope of this particular webinar.
All right, yeah, thank you. So I have one last question. Is VoLTE supported for CBRS, and how useful can CBRS be at high capacity venue events for mobile foot traffic?
So the first part of that, I'll take the VoLTE. So voice and LTE is the way to do voice or telephony on 4G networks unless you don't have a 2G or 3G network to fall back to. And well, certainly where you've got the CBRS band used by a telco, it's just another band of spectrum, and it will connect to the cellular core network and then to their IMS and VoLTE application service. Where it's a little bit more opaque is where you have pure enterprise deployments of CBRS, let's say in a factory. And then the question is, will they support telephony? And if so, how is it going to be delivered? Will they have some sort of enterprise IMS and VoLTE function? That's something I've been talking to people about recently. It's theoretically possible, but it's not easy. So yes, it can support it. The question is, how many enterprises are going to want to start hiring IMS engineers for a private IMS, or will they be able to get that delivered as a cloud service from someone, or will they just use it as a connectivity layer for data connectivity and run their normal voice over IP soft phones over it, which I suspect quite a lot of people will probably do initially. So I think that that's a really interesting topic, but it's that whole intersection point of unified comms, voice, video, collaboration, and private cellular is an area of great interest to me, but it's not something that there's any definitive answers on today.
Okay. Well, thank you very much for answering this question. Big thank you to our presenters and to you, our attendees, for joining us on today's webinar. And I hope to see you at the next one. Bye, everyone.
Thank you. And you've got both our contact details there. Thank you very much indeed.
Thank you, guys. Don't forget to follow us on Twitter, add us on LinkedIn so we could keep in touch.
Excellent.
And I hope you enjoyed this webinar.
Fantastic. Thanks, Jovel. Thanks, Clarice.
Okay,
Thank you. Bye, everyone.